Good evening, everyone. Welcome to the DuPage Valley Observatory of the Naperville Astronomical Association here on our Astronomy Education Center campus. We're going to do some live streaming from our video setup tonight. If you were with us a couple of weeks ago when we tried this, we managed to get some images, but we think we figured out how to present things to maybe a little bit better. Just as an introduction, you probably already know who we are since you're watching this video. We are the Naperville Astronomical Association, your area amateur astronomy group. We have our observatories here on the south end of Naperville, where we've been for 47 years. And we are just an amateur astronomy club, and we like to share our observing with people. Normally, on a night like this, we would have invited you out here in person to look through our telescopes and see our imaging, but we're doing this virtual now in our era of being locked down. What we got here is a building with our telescopes in it. This telescope setup here is totally designed for doing video astronomy. So instead of having a place to look through the telescope, we have cameras in the telescopes taking images for us. So tonight we're going to be sharing you some viewing with that. You'll also get to see the process of finding things. We started out tonight by actually being more prepared than we were the last time. We're not starting from scratch and tuning everything up like we were. We've got the telescope going already, and we've got our first object on the screen. What we've done is we've set up a separate monitor in the adjoining room, and Tony's got his camera in there, and Jim, who's in our control room in his house, can switch back and forth on the views. But I've got a monitor here that I'm using to aim the telescope and get the images looking good, and then we've got the second monitor in there. The images will look a little bit different on here. We might zoom in on this sometimes occasionally through the evening to show you a different perspective. We tried to get as good an image as we can on the monitor in the other room, which has a camera looking right at it right now. And again, Jim will switch back and forth between those. The first object for the evening already here, we've got a star cluster on the screen. And you look up in the sky, you see stars scattered out across the sky. We're looking at a little tiny spot in the sky, smaller than the space the moon takes up in the sky. And we've got what's actually, you can't see them all, but what's actually much close to 500,000 stars on the screen here. The object we're looking at here is called a globular star cluster. It's this particular one goes by a couple of designations. We oftentimes call it Messier number 3. It's on Charles Messier's list from the 1700s of things he saw in his 6-inch or so size diameter telescope. Its official name is probably better to refer to as NGC, I've defined the number here, 5272. And what globular clusters are they're part of our galaxy, of our Milky Way galaxy. We can see about 200 globular clusters. Our Milky Way galaxy is flat, like a pizza. It's a large flat disk. It has spiral arms within that disk. Almost all the stars and the gas clouds and the star-forming regions and the dead stars in the galaxy are in that disk. But the globular clusters actually float around that disk in a sphere. So looking out in different directions above and below the disk of our galaxy, above the plane of our galaxy, we see these floating out there. M3 is, I have written things down here, so because I'm not good at remembering numbers, it's about 34,000 light years away. So the light from this object that the telescope is gathering and focusing on its camera right now for this live image has been traveling across space for 34,000 years to shine into the telescope and get caught. If you were out here tonight, we could be looking at this in our other building with the visual telescope, and you'd be looking at this object. It wouldn't look quite as bright, but you would see the stars in it, and the light shining in your eye would be 34,000 years old, which is kind of a cool thing about astronomy, is you're seeing really ancient things. Let's see, interesting notes. There's about 500,000 stars in this cluster. It's a larger globular cluster. From one side to the other of this big ball of stars is about 180 light years. So if you were on a planet that was orbiting the star over here on this edge of it, and you turn on your flashlight shining this way, it would take 180 years for the light to shine over the other side of the galaxy. The other interesting thing about globular clusters like this is they get what looks quite tight to us in the center, but you have to remember we're looking at this from a long ways away. So if we see two things that are separated from each other, they're actually quite far apart when you get out to that distance. So if you were on a planet that was orbiting one of these stars, even close into the middle of this dense ball of stars, you wouldn't have 1,000 suns in your sky. You just have a lot of bright stars. Like if you go out tonight and you saw Venus setting over in the west, or you see Arcturus or some of the other bright stars in the sky, your sky, if you were on a planet going around with these stars, would just have more bright stars in it like that, but you'd still have nighttime, and the stars don't crash into each other either. They're actually very old stars in globular clusters. I did want to point out that, and I should have opened this way, if you have any questions, if you're on Facebook, post them in the comments section. We're right along with this video right now. Jim back in the control room is following the feed on Facebook. And if you post something and he catches it and he thinks it's of general interest, he'll pass it along to us and we'll try to answer it. Or he might try to answer it there from the control room too. If you don't, if you're not on Facebook, if you're watching from our stream on our club website, or you'd rather use email, you can email us at questions@paperastro.org. And Jim is also watching the email feed for the club and can pass along questions that way too. So feel free anytime to put in questions. Again, there's a few of us out here. Kurt is behind the camera today or tonight. Tony's in the next room with the camera on the other monitor there. So between the three of us and Jim, we might be able to answer questions you have.
Has Jim given a look at this one?
Tony wants to know if you've switched over to the other monitor yet to show them.
Yeah, I have it on a split screen right now.
He has it on the split screen, so he's looking at both of us.
Okay.
So keep your clothes on. So I think we'll move. I explained the last time we did this, a week and a half ago or 2 weeks ago, whatever that was. The sky we see in the evening changes throughout the year. The constellations that are overhead are different in the spring, in the evening, than the evening sky in the summer or the evening sky in fall or winter. In the spring sky at this time of year, we look up and what we end up seeing is a lot of galaxies because we're looking out of our galaxy and we're seeing more empty space and then the galaxies beyond. So tonight we're going to hit a few galaxies and a couple of globular clusters because that's kind of what's outside of the plane of our galaxy. I'm going to make an effort to go to the next object now. So what I do is switch from the view that the main telescope is giving us now, this close-up view of this object, to a wider field camera that shows me a wider swath of the sky. Again, this screen you're seeing is about a half of the size of the diameter of the moon across. So it's looking at a pretty small spot in the sky. So I'm going to switch to a camera that it's going to look much brighter on the screen when it comes up. But this is our finder camera, and it is looking at about the field of view that a pair of binoculars would look at about 5 degrees across. The little cross in the middle, if you can see that at all, shows the size of the view of the main telescope. So we're trying to aim a very small spot accurately. So we do that by aiming a wide spot first. So I'm going to flip over to the constellation of Leo and try to find a.
Hey, Drew, can you turn the other camera to the finder too?
Sure.
Turn the other TV to the finder.
I should have just done that. So yes, if you're watching finders, you're going to see lots of things swinging past. What I'm actually going to do is look up at the sky and see the constellations. The roof of the building is gone. We are in our roll-off roof observatory, which, just as it says, the roof goes away. So I've put a bright star, a relatively bright star that I can see in the sky up on the screen, and I'm going to use that to guide me to the object I want to see. And then I push the telescope by hand to get there. I'm going to see if I can do this a little bit more rapidly than we did last time. I'm looking at star charts here on the table that show me the patterns of the stars and show me where the objects are I want to see. Now, this galaxy that we're going to look at is called Messier 65. And it's in a group of a lot of galaxies. And actually, I think I'm looking at it right now. Let me see. Yes, I have to adjust my camera a little bit. But if you were here the last time we were out here, it took me considerably longer to do that. But again, we're set up a little bit better than that. I am making a blur on the screen because I'm centering in the object. I also switched cameras, so we're not having the menu come up on the screen, which was very annoying before. Now I'm going to adjust the brightness of this image.
Can you flip the other room camera over?
Oh, the other room camera, yes. Back to all right, I just made that a little too bright. So, going from looking at the globular cluster, we're going to look at a whole galaxy. This adjustment takes me a moment to get it tweaked just right because the camera, even though it's a video camera and this is live, I've slowed it way down. Instead of sending 24 frames a second, 24 pictures a second, it's only sending a picture every 6 seconds. So it lets that do a time exposure for 6 seconds and then sends it along. That's one of the ways we get the brightness here. So, Tony, can you see the galaxy on your monitor?
Looks pretty good.
All right, so this is not a cluster of 500,000 stars. This is a whole separate galaxy of more than 100 billion stars. So, like our galaxy, it's billions and billions and billions of stars. It's billions of cubic miles, or whatever you want to say, of hydrogen gas and dust that haven't yet formed into stars, or is the material left over from exploded stars. It's a disk, like our galaxy. It's a spiral galaxy, but we're not looking at it straight on like you're looking down at a pizza. It's tilted away from us quite a bit. So it ends up looking like an oval on the screen. So what you should be seeing, the orientation here we've got is fairly vertical. That's just random. There's no up and down in space. So when you do this for long, I think most astronomers stop thinking about up and down and back and forth and the front side and the back side of things. Everything is floating out in the universe, and there is no up and down in the universe. I'm sorry to flat earth people who think that the universe has a basement and everything falls down there. It's not like that. Everything is just floating. So there's no way that galaxies all have to sit in the same direction or something. They're in every possible orientation. So, oh, there goes probably a satellite went through the field. Or that might have been a little meteor, actually. But no, that's a satellite. It's getting brighter and dimmer there going past. The little line stretching across the bottom. It's a little tumbling satellite. So anyway, our galaxy is a disk that's tilted away from us pretty far. So it looks like a tall oval. Its spiral arms of a galaxy are actually fairly faint, relatively faint. The nucleus, or the center of it, has a higher density of stars, so it's brighter. So most galaxies will look, many galaxies will look like this in that they'll be fainter where they extend out into space, and right in their heart, they'll look brighter. But you can actually just start to see a little indication of some of the dust lanes in this galaxy. We have some haze tonight, which isn't helping us see things well, but there's a little detail still coming through here. The image actually I can see stretching pretty far up and down the screen, but again, it gets brighter as you get closer to the center, so you may be losing that. Are we still getting flicker on this, or is it looking better tonight?
I don't see any flicker.
Oh, that's good.
There's
one
a,
of the
there's a really faint line that goes
a
through,
little lines going up. Well, that's
but
not so bad.
it's faint compared to last time.
Not going to give anybody a seizure from the screen flickering. So again, whole other galaxy, and details about M65. Its proper name is NGC, or New General Catalog 3623. We're in Leo, the constellation Leo, looking up almost overhead. I was picking out things that were up high because that image is better for us. It is about 35 million light years away. So this is the light of actually billions of stars. It looks faint to us because they're very far away from us. We can't see any individual stars in the galaxy. Every other dot on the screen that's a star is in our galaxy. We're looking through our neighborhood. It's like looking through the woods and seeing the town out beyond there. These are the trees and the woods right around us, the stars in our galaxy. And then there's a lot of empty space, and then out there floating in the universe is this other galaxy. Again, about 35 million light years away. So the light coming into the telescope here is old light. It's been making its way across the universe all that time to shine into this telescope so we can see it tonight. Just outside of the field of view here are actually two other galaxies. If you have a telescope that can do a wider field than this, you can actually get this in with its neighbors. This is M65, M66 is next to it, and NGC 3628 is also nearby from our perspective. Those three are probably held together or interacting gravitationally because they all seem to be at the same distance from us. And it's not unusual for galaxies to be in clusters. And there's a lot of clusters of galaxies up in Leto, in Virgo, and in Coma Berenices above us. It's the land of many, many galaxies. So that, again, M65. I was going to go next to back to a globular cluster just to keep things mixed up. So I have to change charts. And once again, if you have any questions or comments, feel free to put them in the comment section on Facebook. And Jim will pass them along. Okay.
We do have a question that just came in from David. He said, how would the view of a galaxy look to the eye instead of to the camera? Could I see it with my eye in a telescope?
Yeah, this is a relatively, so what determines whether you can see something, but including our eye, is how big it is in the sky. If it's very small, you may not be able to magnify it enough to see it, but also how bright its surface is. And this is a fairly bright galaxy. I thought it'd be an easy thing to pick out tonight, even if the clouds got a little hazy on us. You can see this galaxy in a telescope that's only a few inches across. Not from suburban Chicago, but if you go to a darker location. I have a telescope that's about 3 inches across, that has a lens in the front that gathers. This telescope has a 12.5-inch mirror gathering that much light for this camera. I've seen this object pretty plainly. Actually, in a really dark place, you can see this in binoculars. If you're in a really dark place and your eyes are really used to the dark, it makes a big difference. Faint things like this, to the eye, will always be black and white. You won't see any color in it. Partially, the light from this galaxy is the average light together of all sorts of stars and nebulas, which ends up being kind of whitish anyway, maybe a little yellowish. But the color is too faint for your eyes to see it all. If you looked at a picture that the Hubble Space Telescope took of this in color or in artificial colors, where they have to kind of substitute colors that we can see for the colors the camera sees in the telescope, it would be a very colorful object. There'd be pink areas where stars are being formed and bluer areas where there are young stars and things like that. But all of that light is too faint for our eyes to see the color in, so it would just be an image. This camera is actually a black and white camera we're using tonight. The camera we had on here 2 weeks ago was our color camera, but even for these cameras in live video, we're not going to pick up color on a faint object like this, so it'll be a gray hazy thing. I don't know if it's getting too far afield, but the interesting thing is this galaxy would look pretty much that same way, even if you got fairly close to it. Even if you got to the point where you could see it stretching across your sky like this, it would still be a faint, hazy gray patch. It wouldn't be all colorful. It wouldn't look like Star Trek or Star Wars or any of the movies where you're flying past. You fly past nebulas in our galaxy in your spaceship, they're really not very bright. You'd look out your window and you wouldn't see big, immense blue and red clouds. You'd see gray haze because that's how bright they really are. The big colorful thing comes from having cameras that can take long exposures and seeing way more than our eyes can. So I think that got far afield. But anyway, you would see this. I've seen this as an oval patch like this with a brighter center, even in a fairly small telescope. It has to be a fairly small image in the small telescope because if you magnify more, that spreads the light out and gets really faint. If you want to see it bigger, you need a bigger telescope to gather more light so you can spread out the image more, because you only get a certain amount of light, and if you spread it out by magnifying it, it gets fainter and fainter and fainter. So I hope that answers the question, though. This is something you can see. I've seen it, again, I might have even seen it in binoculars, because I've been in places that are so dark that I've seen a lot of the Messier objects like this in binoculars. But again, it would be a tiny little hazy patch when you're not magnifying it very much. Although this isn't really very small. Again, if this screen is about half the size of the diameter of the moon, this thing is pretty big. You could paste it on the moon there and you would see it as a big thing. It isn't like it's a tiny speck way smaller than the moon. It's you know, probably the extent of it you can see is about a quarter of the diameter of the moon. So that's actually fairly big. But again, not very high, what we call surface brightness on it, especially not compared to the moon. Okay, we're going to flip to the next object. Okay, Homo Berenices. I have to get my chart oriented in my head. So we're going to go back, we're going to do a different globular cluster, just because I didn't want to do entirely galaxies. All right. To figure out what stars I'm looking at here. And then I have to look at the sky. So, what are you? Chart I'm on. Again, if there are any other questions.
Jay joined a little bit, or sorry, DJ.
Okay.
Oh, wait, who am I talking to? No, Jay joined a little bit late, and he asked what galaxy that was. So that was M65 in the constellation Leo.
I'm just looking for a star up in the sky. My eyes are not very used to the dark from, well, it's up here somewhere. We're going to go back to the finder view on this telescope.
Can you flip both finders?
I'll be flip the other one too. Okay, there you go. And we'll dance around a little bit. As I pointed out when I was showing people around here last time, we would normally want it really dark in the observatory so our eyes can get used to the dark. But having the TD monitor does not make that work too well. And also, having the camera light kind of takes away the night vision a little bit. I've got a really bright, oh, let me get this really bright satellite. There goes the satellite. Going past on the screen. If you can see that.
Yeah.
So, yeah, so everything goes by. There's that satellite. So that looks considerably brighter on the TV screen than it does to the eye, fortunately. Wow, I'm really having trouble seeing. Bella Berenices is a constellation. It means Bernice's hair. I can't remember the story of who Bernice was and why her hair is in the sky. That's something to Google. So, all right. It's got to be. There's a star there somewhere. Where's the star? We have to start the next star down and hop up. So there's a star. We'll do that. Okay. Charts. So I'm looking for star. I'm hopping my way. To, I think, here. I have to switch back charts.
Got another satellite going through.
Yeah, there's a lot of stuff going over. Stars. Yeah, I should be close to this object right now. Let's see. Oh, there I am, quite close to it. So I've got it at the top of the screen. I'm going to slew the telescope down and over a little, so it's gonna. It's again, the camera is slowed down in video, so when I move the camera, it just makes a big blur. But it'll settle down in a moment. And after a couple seconds more, we'll get a better image of this object. I think I can turn up my exposure just a little bit, or maybe not that much. See if this settles down. We're losing our focus a little bit. So that, as I explained the last time we did this, the telescope actually changes shape ever so slightly as the temperature changes. So as it gets cooler out, we occasionally, or it gets warmer, if you happen to be observing when it's getting warmer, we have to occasionally refocus it. So it's kind of like tuning your stringed instrument while you're playing it, because you want to keep it prime. So this looks a lot like the first thing we looked at. It's a little smaller on the screen. M53, here we go. Its proper number is NGC 5024, it's a globular cluster. So this is quite a bit farther away than M3. I said M3 was about 34,000 light years away. M53 is, this one is around 58,000 light years away. So it's also a big globular cluster, but it looks smaller to us because it's farther away. Again, another factor about this telescope, more people who come visit us a lot, but it's worth repeating some things. Telescopes like the one in our other observatory that we use visually, we can change the magnification on them by changing the eyepiece set that we look through. So if we want a lower power to see a wider sky, we can put in an eyepiece that does that. If we want to have an eyepiece, or we want to have the view that's zoomed in more and magnifies more on something small, we can change it to an eyepiece that does that. This setup with the video work we can't do that. There's no eyepiece. The camera is right where the eyepiece would be. So the light from the telescope is focusing right into the camera. So we're stuck at the same magnification all the time. So for something like, oh, it's a little blurry here, the wind is catching the telescope a bit. So sometimes the frames will blur a bit from the telescope shaking. So that's due to that. Anyway, back to what I was saying. If you have two globular clusters and one is twice as far away as the other, or half again as far away, like this one is going to look half again smaller because it's that much farther away. So that's what's going on here. So it's not taking up as much of the screen. I've viewed ones around our galaxy that were so far away that they looked like a tiny little fuzzy patch, much smaller than this yet, just because they're farther off in the distance. So that's an interesting thing. Again, remember, we're in the universe. There's no room that we're in or something where everything's close by. There's things closer and farther and farther and farther as we look out. Globular clusters like this are made up of still the original stars that formed in them. This globular cluster is probably about 12.5 billion years old. So it was forming while our galaxy was just initially forming. And the stars in it formed at that time. Globular clusters don't end up with any gas clouds left in them. They're not that big to form new stars. So they have their original set of stars, and that's pretty much all they have. Any stars in there that were really big to start out with would have burned out already. So this is more middle-sized stars that can last for quite a long time. Again, almost all these stars are that original first generation. So they're about the same 12.5 billion years old that the whole cluster is. So we're looking at kind of, they're sort of the antiques of the galaxy. And that's also one reason they're not in the spiral arms, because the galaxy was just forming at that time and flattening out into its spiral arm shape. So again, we're in Coma Berenices.
Drew?
Yes.
Drew, we have a question.
Sure.
I'm going to change kind of how he asked the question a little bit, but David was asking, how do we know the distances? So how do scientists or astronomers, how do they measure distance in space? Can you kind of talk about that a little bit?
Sure. You can look at it really simply. It's really hard to do. So it really depends on what part of the universe we're looking at. The planets in our solar system, we can measure using simple surveying techniques pretty much. We can see them going around the sun with us. We can see how they change position over time. We can do the math to figure out. We know the distances to the planets really well just from using, like I say, surveying techniques. When we start to get to other stars, so that's a jump from the things going around our star to other stars, there's actually quite a range of stars now around our sun in our neighborhood in the galaxy that we can also measure using surveying techniques. Actually, it's done now by satellites that orbit the Earth, but you look at a star in, say, the springtime here, and then you look at it again in the fall, and you see if it is shifted in its position against the farther, more distant stars because of parallax, because you're looking at it from this angle and looking at it from that angle. And we know how big the solar system, or the Earth's orbit is quite accurately. So we can use, again, surveying techniques, trigonometry to figure out the distances to stars like that. When you get beyond the range where you can do that anymore, which these guys are, you have to start looking at the stars and the brightnesses of the stars, trying to figure out how old is this star, how bright should a star be that's that old? Does this one look, how much dimmer than that does this look? Because the farther away something gets, the dimmer it looks. And that's very much a geometry thing too. If you're twice as far away, you look a quarter as bright. So you say, how bright does it look? How bright should it look in theory from what we know about how stars work? So you do that out into stars like this because, again, they're too far for us to, we don't have a baseline to look at them from this angle and from that angle for something that's this far away. Then you get out to things like other galaxies, and you're definitely looking at stars in them. The whole expansion of the universe theory was developed, and I use theory in the scientific term, a concept was developed by realizing that we could see individual stars in other galaxies with a big enough telescope. So we can start looking at the stars in other galaxies and saying, what kind of star is this? How bright should it look? And how bright does it actually look? And figuring out the distance to it that way. There's a lot of steps and different techniques along the way for doing that and relating one scale to the next. But astronomy it's amazing how good we are at doing some things when we can't touch any of the stuff out there. We can't touch this. We can't go out there and look at it from the other side or measure it or whatever. Everything we do in astronomy is done passively by looking at the light and the other colors of light, the other radiation that's coming from these stars and objects from space. So it's amazing that we can do as much as we can do. On the other hand, if you're, say, a physicist or a chemist, you can think astronomy is kind of a joke at how inaccurate some of it is. There are some things we look at. Well, a lot of these objects, if you look at a book that's 10 years old, it'll have a different number for how far away this is than a book that's 25 years old, and a way different number than the one that's 50 years old is, because we keep on developing new techniques and trying to look at it from a different way and using a different technique that's more accurate. So our accuracy, we wouldn't have gotten to the moon if our engineers only had the accuracy that astronomers have in numbers on some things. But we do know an amazing amount. But I'm never surprised when I read something that says, last year we said this was 58,000 light years away, but this year we've decided that 62,000 light years away, because that does happen quite a bit, because new techniques come in for trying to be more precise. I hope that answered that question a little bit, but it's a great thing to Google, measuring astronomical distances, because there's a lot of story to it, a lot of different things involved. So here we are at a little after 10, and in Bernice's hair, I was going to go to another galaxy. Last time we were here, we did the Whirlpool Galaxy, which is up under the Big Dipper. I thought we'd give that another shot this week and see if we're a little less flickery on it, because it's a very pretty object. It's also later at night. When we were imaging it last, it was still kind of light out, so it was not optimum time for doing it. So we're going to go to M51, or the Whirlpool Galaxy. Pull out my chart for that. Even though I should be able to find it, I have looked at it so many times. I want to be relatively confident that I can do it effectively. So I'm going to go back to my Finder camera. I will put it on both views. And we're going to swing around a little bit. So right now, tonight, if you go outside, the Big Dipper is straight, a little bit north, but pretty much as high in the sky overhead as it gets. I'm going to go to the N star in the handle and put it on the screen here. That's my starting point, looking at my charts. I don't know, you could try to show the charts. Let me see. I'm not the one that puts does that pick up at all?
Mm-hmm.
So the black dots are the stars. This is the sky reversed, because it's easier for somebody reading a chart in dim light to see black stars on a white background and black writing on a white background than it would be to have a black background with white dots on it, writing. So this set of books divides the entire sky up into almost 400 different pages. So it's kind of zoomed in. It gives a lot of detail. There is one star on this page that you can see when you look up, and that's this one here. And so I pointed the telescope at that. The object we want to see is down here. So I'm going to use this as a guide as I look at the screen to get down here and make sure I'm centered in the right spot to see that object. But Star charts are a key thing unless you're letting a computer do the aiming for you, which we don't have in this observatory. So anyway, I'm going to go from that bright star. I didn't need to center it on it. I just need to see it over to these two stars here, which I see in my chart. And then I know that down here off the screen, there's another little group of stars. So I'm just going to push the telescope up. So I see this little group of stars. And what I'm looking for is there's a little triangle of stars below the cross here. And the object we want to see is right down on this triangle. Well, here. And all I have to do is be close enough that I get.
There's a satellite going through?
Yeah, oh, it's about to hit the object we're looking at. Yep, another satellite. So this is a north-south satellite heading south. Most of those are either spy satellites or the kind of satellites that take your Google Maps views of things. So they go around the Earth from pole to pole, and the Earth rotates underneath them, so they scan the whole Earth as the Earth rotates underneath them, and they're taking pictures along the way. There's a little bit of space trivia for you. So I'm going to switch back to this view, and oh, look, I found it. Not quite centered, but I'm going to blur it for you here for a moment. Get more on screen. Again, it's not going to blur till it catches up with me. So what we're looking at here is called, you're not seeing it well, don't worry that you're not seeing it well. It's going to have to settle down for a moment after I get it centered. There's a set of motors on the telescope that let me push it very slowly and gently to get things centered on the screen, more gently than I can do with my hands. So this is another object that has a Messier number. It's M51. Its proper number is NGC 5194. It's got a common name of the Whirlpool Galaxy, and if you're starting to see it on the screen, there might be an obvious reason for that, because it looks like a spiral. So again, one of the main types of galaxies that we commonly see are the spiral galaxies, like our galaxy is. They're flat disks like pancakes, but they have spiral shape in the arms that surround the nucleus. The nucleus is brighter in the center. The spiral arms wrapping around it are a lot fainter in the middle. The Whirlpool Galaxy is a little closer.
We're having your camera cut out just a little bit, Drew. I think our bandwidth has got a little funny.
Okay.
Let's give it just a second and see if it maybe catches up with us. Okay.
It's Tony. He got too close to it, I think. So,
What's he saying going on with the camera?
He said my camera's bandwidth is cutting out. So. You're blocking the cell phone.
Metal plate in my hand.
Okay, I think we're back good again. So
a little more smoothly. I will try to speak slowly. Back to galaxies. There is a little bit of blurring going on in this image because of the wind shaking the telescope some, but it settles back down. It does that. Anyway, so spiral galaxy, flat disk. The center will oftentimes be brighter because the density of stars is better. Our imaging now, even this, with a fairly simple video setup, is a lot better than imaging was 50 years ago in using film or glass plates to take regular photography. To take pictures of faint things, you would have to take a very long exposure, and you'd have trouble getting the bright parts and the faint parts exposed the right amount. So if you see drawings and books of what a spiral galaxy looks like from the side, from a book from, say, the 1960s or before, or even the 70s. They'll show a flat plane of spiral arms looking at it again from the side, looking at like from the crust of the pizza, with a big bulge in the middle of it where the nucleus was. In reality, there isn't a big bulge where the nucleus is. It's almost no change in thickness of the galaxy, just that the photographs would have to be so overexposed in the middle to catch the outsides that they would bleed out and make a big blob there to be able to see the spiral arms. Now we can just see that they're fairly flat, but they're just much brighter in the center. This galaxy, again, we can see the spiral arms of it because we're looking straight down on it just by random chance. Some galaxies we're looking at from the edge, every angle in between, and some almost straight down like this. So we're looking at it from the top. We see above it another fuzzy spot with another bright center. That's a dwarf galaxy that has run into the main galaxy here. There's actually an arm that connects the two. They're at the same distance from us by looking at the stars in them. And a good photo, if you look at the Hubble picture of the Whirlpool Galaxy or M51, you will see it very well delineated how they're connected together. Gravity draws things together in space, even though space is expanding. So when galaxies are in clusters, they can end up running into each other. What will happen eventually in millions of years' time is these two will oscillate back and forth together, and they'll eventually merge into being one galaxy. But we're seeing them in the middle of that process, kind of this snapshot here. Oh, I was talking about the distance. This guy is only around 30 million light years away, as opposed to the, what did I say, 35 million for the first galaxy we looked at, M65. Let's see, what else do I have interesting about this? Again, there's more than 100 billion stars in that galaxy. As we're figuring out, it seems like almost always when stars form, planets form around them. So probably almost every one of those stars has planets around it. So there's hundreds of billions of planets in that galaxy too. As far as the merging goes, these guys are close together. If we look up in the sky in the fall and see the Andromeda Galaxy, which is the biggest or the nearest other spiral galaxy to ours, you can actually see with the unaided eye as a oval in the sky. It's actually approaching us, or we're approaching it, we're approaching each other, and we'll eventually collide with it, and it'll do the same thing as this. The galaxies will basically pass through each other because most space is empty, even in a galaxy. If you look up and you see the stars, they're really pretty far apart. So two galaxies can just kind of pass through each other, but the gravity will sort of tear them up, and then they'll end up merging into being one. So, but don't worry about that. That's a long time off. So that's M51. I guess we've got time to do yet another object or two. Gee, I'd take a vote if I think maybe we'll go to another galaxy that's not terribly far from this. Oh, I should have pointed out the constellation we're in is in Canis Venatici, which is the hunting dogs. They belong to Pleiades, who's the herdsman, who's the next constellation over. Canis Venatici, which is underneath the bowl of the Big Dipper, the handle of the Big Dipper, is dogs. I was going to find another galaxy in this constellation, which is kind of pretty. Which one? I guess we'll go to M63 next. So, I have to change pages. And it's gotten breezy again tonight. It was breezy last time we were out here. Okay. I have to find my galaxy on this page. I wrote down that it was on this page. Oh, that's I'm looking at the wrong page. 76. So sometimes some of these pages have lots of galaxies on them. So take me a minute to find the one that I'm looking for. There it is. Especially in dim light, because my eyes aren't what they used to be. Okay, so I'm actually on the same page in the book as this galaxy is. We would say sun looks like. I'm going to go back to my Finder view. Finder view in there and Finder view here. Wow, the wind is really picking up. I'm sure that says 63 by. So, looking at this view, I want to go down to these two stars here. I want to go over this way a bit, and then down to two bright stars there. I'm just trailing down my page to get me this neighborhood. Those three. There's not a lot of stars around this guy, so he's a little harder to find. Okay. We have a variable star here. It's way brighter on the chart than it shows up. Well, we're going to go look at this. It's right about where the galaxy should be. And it's got a supernova in it. All right, so I'm going to go back to here's our bright star. I'm just trailing off. So that must not be bright star. I don't remember there being a bright star on top of this galaxy. I'm going to make it above the screen. It's me blurring it on purpose.
Can you flip the other camera?
I can. It's not very interesting at the moment. It's a squiggle. So,
The Squiggle Galaxy, is that?
it's the Squiggle Galaxy. It's a new discovery. I'm confused. I have to look at my chart again. It's very confusing. I'm going to blur you a lot so I can see what's in the stars.
Got some thin clouds where you're looking too, Drew.
I think maybe that's why it's looking different than it should. Oh, that's okay. Never mind. I want to be down here. I just can't see the star that I should be able to see. That's right. Now I don't know what you're seeing on the other monitor. Besides squiggles. All right, that's the star that's close to the galaxy. Okay? So the galaxy should be over this way. Come on. You can move. Yeah, I think you're getting a little dimmer here than maybe. Oh, I see the clue. Galaxy out here somewhere. Well, maybe we're losing it to the haze. We should go to something brighter. So we're in the right spot. I'll go back to my timer, make sure I'm not screwing this up somehow.
So we're at, it's 10:27.
Okay.
I don't know. Might be a good time to just call it if you can't find it, if it's starting to cloud up.
It is getting a little cloudy. Give it one more try. Oh, here's the easy spot. Let's see what happens when, there it is. I'm going to center that. If I can.
What object is this?
Okay, so this is M63, which is another galaxy. It's also in the hunting dogs, Canis Venatici. So that's the star I was looking for. That's right next to it. I'm going to get it into the center and then we'll let it stabilize. And then it'll be our final object for the evening. Okay, give it a few more seconds here to settle down. So here's another spiral galaxy that'll be coming into view. You're mainly going to see the bright point in the middle of it. This one's nucleus is so compact that it looks like one of the stars on the screen, really. Its arms are tilted away from us fairly far, so it makes an oval on the screen. It's brighter. The disk is brighter around the nucleus. It's bouncing in the wind a little bit, so it still has an area of stabilizing. There's a circle right around it, which is its inner arms. Its arms actually, if it was a little less hazy at the moment, and you could see the screen a little more clearly, its arms would actually fill up quite a bit of the screen down here because they just fade out more and more as they get away. It's tilted away from us, so again, it looks like an oval rather than either the face-on disk or the edge-on lane of it. So again, we're in the constellation of Canis Venatici. This one is at a similar distance to the first one we looked at, which was M65. So it's over 30 million light years away from us. And again, more than 100 billion stars on the screen at once. So I guess we're going to call it quits after an hour. We managed to get through a number of springtime objects. We sincerely hope that we're going to be able to do our open evenings back out here again for terribly much longer, but obviously we're being prudent about that. It'll be safer to be out here in the wind probably than before we're gathering in rooms again in enclosed spaces. But follow us on our club website calendar. We'll keep you informed on Facebook. We will do more pop-up events like this as time allows. We're experimenting with trying to offer you some daytime observing of the sun. We'll probably be doing that before long. The only caveat about that is the sun is in its minimum of its 11-year cycle of having a lot of sunspots and having no sunspots. And we've had many weeks this year when there hasn't been a single sunspot on the sun, so it's not as interesting to look at. There's not as many prominences coming off the edge of the sun, things to view. But we're going to try to offer you some of that before terribly long, too, when we have a nice sunny day and we get our act together for offering that. Again, follow us. We'll be doing more pop-ups with short notice. So like us on Facebook if you haven't already. I know Facebook is funny about what they show you, even when you like things. But you might even check on our page on Facebook every once in a while to see if we're posting that we've got a new event coming. Otherwise, thanks very much to Kurt and Tony and Jim for making this possible by doing the engineering stuff. And thank you very much for joining us. And I guess we'll sign off now. Take care and keep on enjoying stargazing.